Welcome back, guys. So this is the question number 51, in which we have to convert each of the BCD numbers to their decimal counterparts. Okay, so previously we have seen that how to convert each of the BCD number to their decimal counterparts. So again, let me write them here. For it, I am selecting this white color. So here we have here, this is a decimal number, okay, and the BCD numbers here. Okay, so we have 0. For 0 we have 0 0 0 0. For 1 we have 0 0 0 1. For 2 we have 0 0 1 0. For 3 0 0 1 1. Okay, after it we have 4, and for 8 this bit will be 1 while the others will be 0, and for 5 0 1 0 1. For 6 0 1 1 0. For 7 0 1 1 1. Okay, for 8 we have 1 0 0 0, and for 9 we will have 1 0 0 1. Okay, so up till this limit we will have all the numbers which are included in the BCD, and their counterparts are also available in the decimal as well. Okay, after it, whatever numbers we will get, those will be the invalid BCD numbers. And what are those numbers? So let me use this red color for it. So for those, let me have here 10, and for 10 we have 1 0 1 0. For 11 we have 1 0 1 1. Okay, for 12 1 1 0 0. For 13, for 15 and 14 and 15, let me write them here. It will be 1 1 0 1. Okay, 1 1 1 0, and for 15 we will have 1 1 1 1. Okay, so all the numbers beyond this limit are the invalid BCD numbers. Okay, because their validity in the decimal numbers or in the BCD are not proved. All the numbers in the BCD will be composed of the combination of these numbers. Okay, those will be the combination of these numbers in the decimal, and writing their codes will give me the decimal numbers. Okay, so all the numbers here are basically decimal numbers. So what if we will get any numbers from this invalid decimal number? What we have to do, we have to add, okay, 6 with it, 6 with them. Okay, so in binary, what is the equivalent of 6? In binary, the equivalent of 6 is 0 1 1 0. So there we will have to add this number with it. So this is the range, and by keeping this range in mind, let me solve our part A here. So in part A we have 1 and all the zeros here. Okay, so 0 0 0 0. So now what we have 1 here. This is basically an 8-bit number. Here we have the MSB as a 1, while all the numbers here are the zeros here. So to solve it, let me write here this with red. So this is the first, these are basically the first 4 bits, while this one is the other 4 bits. Okay, so here we can see that this is what we can see very clearly, that this corresponds to the 0. So therefore in decimal this will be equal to 0. Okay, what about it? This is 1,000,000. Okay, so what is it equal to? This is, now we can see that this is now 8. So therefore writing it here as well, we will get that this is the 80 in decimal. So that is the decimal equivalent of my number, which is here in BCD. Okay, similarly part B here, let me write the part B here, and using the same color here as well. So part B here, I have 1 2 3 4 5 6 7 8 9 10 11 12. This is basically a 12-bit number. Okay, so writing it here, what I will do, let me start it from this MSB. So here it will be 0 0 1 0. Okay, up to this point, then 0 0 1 1 0 0 1 1, and then 0 1 1 1. 0 1 1 1. So you can very easily see that here how many groups do we have here. So let me start grouping them from this lower significant bit side. So these are the 4 bits, okay, these are the 4 bits, and here these 4 bits as well. Okay, now looking into the table and writing the corresponding decimal numbers from them here, this is 0 triple 1. So let me see here that where is the 0 triple 1. Okay, so this is here, we can see that this is 0 triple 1 and this is equal to the 7. This is 7. Similarly, 0011 0011 is here. Okay, and we can see that this is equal to 3, while this is 0010 is how much? 0010 is this 2. Okay, so this one is 2 here. So now this is 237, and this is the answer of my question, that 237 is in decimal is equal to this number. Okay, so that is the solution of part A and part B. So let me remove it now. Okay, let me remove it and let me solve the part C of my question. So for part C of my question, let me write all the bits here as well. So here for part C we have 0011 01 01 000, okay, and 110. So again using the same red color and start grouping them in the form of 4 bits. Here these are the 4 bits, okay, these are again the 4 bits, and these are the last 4 bits. Writing them here, 0110 is how much? So 0110 is this 6. Okay, so this is now 6. Okay, writing them here, 0100 is 0100 is this 4. Okay, this is a 4, and 0011 is this is now this 3. Okay, so this is now 3. So that is the decimal equivalent of this number. For part D here, let me write the equivalent of part D. So writing it here, 0 1 and 1 2 3 4 zeros, 1 2 3 4 zeros, and then 1, and then again 4 zeros, and then 1. Okay, so this is my number. Now again let me write it in the form of the 4 bits group. So this is a first group. Similarly, this one is a second group, while this is a third group here. Okay, so now let me see their equivalents here. So this is now equal to this 1. Okay, writing it here 1. This is 0010. So 0010 is 2. Okay, so 0100 is 0100 is this 4. So this is 421, and this is again in decimal. Okay, so that is the solution of part D. So all the solutions we can see that are going very smoothly, and we are not getting any invalid BCD numbers. Okay, so now in order to check the other numbers here as well, let me remove them. And let me try part E here as well. As you can very easily see that I am looking for the invalid BCD numbers and looking for the question where I will get the invalid BCD number, and to tell you that how to convert those invalid into the valid BCD numbers. So in part E we have 0111, okay, 0101, 0101, okay, and 0100, 0100. So now we have again these 4 bits, these 4 bits, and these 4 bits here as well. So 0100 is how much? 0100 is this 4. Okay, this is 4. 0101 is 0101 that is 5. You can see that this is 5, and 0111 is 7. So again all the numbers are the valid BCDs, and here we have this decimal number. Okay, so after let me solve the part F. So part F is also composed of all the numbers. So here again we will have, let me use this yellow color. Here it will have these 4 bits, these 4 bits, and these 4 bits as well. So here we will get, this will be 8 double zeros. Okay, so that will be in decimal. In G, what I will have, let me solve G. Okay, let me solve G here. So here I will have 1 0 0 1. Okay, 0 triple 1. Okay, and 1 0 0 0. Okay, so now let me group them as well again. So this is a first group, this is a second group, and this is basically the third group. So what here I will have, this is 1 triple 0, 1 triple 0 is this 8. Okay, 0 triple 1 is this 7. Okay, and 1 double 0 1, 1 double 0 1 is this 9. So this is equal to 978, and this is in decimal. So all the numbers here are again the valid BCD numbers. Let me solve the part H here, which are basically the numbers containing the higher number of bits. Okay, so let me remove them here as well. Okay, so we have removed them, and here we can very easily see that this is the part H, and in part H we have 00001. Okay, 0110, 0110. Okay, 1000, 1000, and 0011. So this is a number, and we have to first of all convert it to the groups of 4, and then we have to look into this table in order to see the equivalent of these bits. Okay, so here let me group them here as well. So this is a first group, this is a second group, the third group, and the fourth group as well. So this is 0011, this is this 3, 1 000. Okay, this is 8. You can see and confirm that these are the same numbers. So 0110, so 0110 is 6. Okay, and this is 1. So 1683 is the number in decimal. Okay, so that is the equivalent of it. Now similarly the question here, so let me leave it and start solving this J. So the part J here is 0 11 00. Okay, 0 11 00, 1100 again, 1100 again, 1100, 1100, and 111. So this is a number. Let me group them here as well. So this is a first group, this is a second group. Okay, this is a third group, while this one is a fourth group. So here this one is the 0111, this is 7. 0110 is 0110, so that is the 6. Okay, 0110 is again 6, and this one is again 6. So this is a decimal number, which is 6667. Okay, so that is the solution of part H, and that is the end of our question, in which we haven't found any number which is the invalid. So whenever in our next question, whenever we will have any number which is greater than 9 here, we will add this number with that number in the binary or in the BCD, and we will get the valid decimal numbers and valid BCD numbers out of that invalid number. Okay, so that's it for today, and I will see you with some more questions in our upcoming video. Till then, take care of yourself.